Assalamualaikum warahmatullahi wabarakatuh, and very good evening to Professor Mada Dr. Suraya binti Muhammad Tahir. Today I'm going to present about manufacturing of frying pan by powder metallurgy method for test 2. My name is Muhammad NAJIB bin Ahmad HASAN. My metric number is 189-389. Next, for this presentation, I would like to share about the history, the introduction for this assignment. For my assignment is I'm going to choose frying pan, and the objective of this assignment is to apply powder metallurgy method into the product that are not using the powder metallurgy method. So my product is frying pan. So a little bit introduction for frying pan. A frying pan or fry pan skillet is a flat bottom pan used for frying, searing, basically for frying food. Some recap for history, copper frying pans were used in Asian Mesopotamia before the introduction of the kitchen stove in mid-19th century. A commonly used cast iron cooking pan called a spider had a handle and 3 legs used to stand up in a coal and ashes of fire. This period of late 19th century saw the introduction of the flat casting iron frying pan. So starting from this century, the cast iron frying pan has been developed. So traditionally, frying pan were made of cast iron. So by this assignment, I try to use metal injection molding to produce frying pan. So there are some material construction method used in modern frying pan very greatly, and some typical material include aluminium, cast iron, copper, stainless steel, or some combination stainless steel with aluminium or copper core. So for the frying pan manufacturing using powder metallurgy method, there are 4 to 5 production sequence. As we can see on the slide, they are starting with metal powder, how to manufacture metal powder, and then proceed with blending. And there are 2 sections, which is called compact or hot compact. But for mine is a metal injection molding, and then proceed with sintering, and finally secondary and finishing operation. So for powder production, there are 2 ways to produce the powder metal. So we can use either gas automation, which is use high velocity gas stream flow through an expansion nozzle, siphoning molten metal from blowing and spraying it into a container. Other than that, is centrifugal atomization, use a consumable electrode that rotated rapidly in a helium filled chamber. So this one is from this figure, we can see how gas atomization has been done. There's molten metal and been sprayed by gas and then produce the metal powder. Next, for centrifugal atomization, as we can see in this figure, the fat through the tungsten cathode, and then the gas will be used to make the powder dry. So for the blending and mixing, to make the homogeneous mass in a uniform distribution of particle size and composition, there are 2 ways, not 2 options. There are 2 ways. First, start with blending, intermingling 2 or more powder in the same chemistry, but possibly different particle size and shape. Next is mixing, combining 2 or more powder of different chemistries. So for my process, I choose metal injection molding process. As I've been explained just now, there are, from the top, we can see how the powder has been done. We mix metal powder with binder, mixing, and then we get the feedstock, and from the feedstock, we're going to put in our injection molding machine, and will follow the injection molding, bind removal, and finally is sintering. For each step, I will explain briefly about the process. So first one is preparing the feedstock. The process stop involving combining metal powder with polymers such as wax and polypropylene binder to produce a feedstock mixed with that is injected with plastic injection molding. So for this one, metal molding as a liquid into a mold. The binder is merely an intermediate process aid and must be extracted after injection molding from the product. Feedstock can either be imported ready to mold from a variety of foreign supplier, or metal injection molding manufacture can be manufactured in-house if the requisite expertise and experience are available. So second, the injection molding. The molded or the green part is refrigerated and expelled from the mold. The green from the green metal injection molding part are formed in an injection molding process that is equivalent to the plastic part being formed. The variety of part geometries, which this process can be produced, is similar to the great variety of plastic component. So for the third step is the subsequent process of binder removal is used to obtain part with an interconnected pore network without destroying the component shape. At the end of the binder removal cycle, some binder is still present in the section holding the metal powder particle together, but the pore network enables the residual binder to evaporate rapidly in the initial sintering step, while sintering neck begin to expand between the metallic particle. In the condition called the gray level, the resulting fragile and porous component is called. So point number 4 is the sintering process result in the removal of the bulk of the pore volume previously filled in by the binder. Consequently, during the sintering, metal injection molding part might be exhibit a significant shrinkage. Usually the linear shrinkage is as high as 15 to 20%. So we talk about the advantage and disadvantage of this method for metal injection molding method. So for the advantage, we can see that it very fast production at high output, cost for a labor lower than other manufacturing process. Next is highly versatile and also good consistency of the part produced. But the drawback for this method is it was initially tooling. For initial tooling and machinery costs may be high, and certainly technical limitation for this method. So we can see that this process can be done even with different material. So that's all from me. Thank you very much.